Assuming a substitution of u equals 2x cubed minus 2, which the below is equivalent to 1 to 2 x squared 2x cubed. Okay, that. Okay. So this is kind of not a standard question, but the kind of question a lot of times you'll see on an AP exam. The idea is they give you a really complicated question, and they just ask you to do a small portion of it. So you could think of this as, hey, solve this equation, but instead of you having to figure out that, okay, I'm going to have to do substitution, go through the substitution, and the whole problem, you're just asked to do a small portion of it. And that kind of has its pros and cons. It's kind of disorienting because you're kind of thrown in the middle of the problem, and you kind of got to figure out what's going on. But it's kind of nice because you don't have to do the whole thing. And you're kind of given direction on which way to go. So I'm going to rewrite this for clarity. 1 to 2 x squared 2x cubed minus 2. I know I say for clarity, but my handwriting is terrible. And then they say, all right, we're going to do the substitution of 2x cubed minus 2. So with that said, we have to do the derivative. So taking the derivative of such, we have 6x squared and then dx. And the 2 disappears because the derivative of constant is just 0. Okay? So now, okay. So then we want to solve for, click, clack, x squared dx. So x squared dx. So 1 over 6 du equals x squared dx. Okay? This is, I'm going to call this x initial. I'm going to call this x final. And we should probably convert those over to u's. Yep, because we're given some different, it's probably 0 to 14, but we're given different start points and end points, so we should convert the limits of integration. If you're running short on time, and you're like, oh, I need to get this problem done really, really fast, you could probably look at this over here and be like, all right, the limits of integration probably change, so it's probably not going to be 1 and 2. And the only other choice is 0 to 14, so chances are 0 to 14 is probably going to be the answer for the limits of integration. But it's good to see why. So we'll say here that, let's see, hey, u, I'm going to do it this way. Copy, paste. So we know that u equals this. So I'm going to say u initial equals 2 times x initial cubed minus 2. And we know that x initial here is 1. So this is 2 times 1 cubed, which is 1, minus 2, which is 0. Okay? U final equals 2 times x final cubed minus 2, which is 2 times 2 cubed minus 2 equals 2 times 8 minus 2 equals 14. So our suspicions are confirmed, and we can be reasonably confident that we have 0 to 14. Okay, so putting everything together, we have 0 to 14, 1/6, because we're replacing x squared dx, du, and then we have this part becomes u to the 4th. So 1/6 u to the 4th du, 1/6 u to the 4th du, right here. And so this will be our answer. So to backtrack slightly, we're like, all right, here's this complicated problem. Solve this integral, which isn't that bad. But the problem is telling us specifically, use substitution and use this value as the substitution. And so we do that. And we don't even have to finish the problem. We just, all right, we've proven that we can do substitution. We have to worry about the limits of integration. And we have to worry about basically a constant, moving the constant for the 1/6 over here when we solve the derivative of u. And we put it all together, get our answer. Not too bad. We can do this. Go team.